So we're going to wrap up, getting close to kind of wrap the section up. We got two more things from here. We want to estimate the derivative. So if you want to estimate the derivative, we could say f prime of a is about equal to f of a plus h minus f of a, all that over h, for small values of h. So that's if h is small. So what we're going to do is we're going to estimate the derivative. So for this example here, we want to estimate the derivative of f of x equals sine of x at x equals pi over 6. So, couple ways to do it. We're going to just say, let's choose a value that's for h is small. And with most functions, the smaller you let the h be, the more accurate your estimation is going to be. So let's choose a, okay, so a is going to be pi over 6. And then h is going to be the small distance that we scoot over from pi over 6. So let's make it 0.0001. So that's kind of small. We could make it smaller and get more accurate, but this should work for what we want. So we're going to say, what is f of a plus h? A is pi over 6 plus h is 0.0001. We want to say, what's that minus f of pi over 6? And then we want to divide that whole thing by 0.001, the h value. And this will be an estimation of f prime of 6. The book uses 0.5 for their estimation. Or sorry, no, the book uses, the book doesn't really use a particular value. It just kind of has a table on the next page and uses a bunch of different values and gets it out to 4 decimal places. So what we're going to do here is we're just going to use this for our estimation. We'll get an estimate. If we put more zeros on there and got, the smaller this h value is, the more accurate our estimation will be. But we'll just say for now this is good enough to just get an estimate. So this will be equal to sine of pi over 6 plus 0.0001 minus sine of pi over 6, which sine of pi over 6 should be a half. And that's all over 0.0001. So we're going to put that in our calculator, and it'll tell us an estimation. And again, what does it mean for h is small? It depends on how accurate you want stuff to be and what your function looks like. It's not a good idea to just choose one, kind of like we're doing here with this, and just said, well, that seems like it's small. It's a better idea to kind of have some idea of how accurate you want the thing to be, and then you can estimate it to that degree of accuracy, choosing different h's. So we get 0.866004023. Oops. And so we'll say 0.866. This seems like a decent value for our estimation. And if you check that with the book, it lines up and agrees with what they're doing. So again, the smaller we chose the h, the more accurate we would find the instantaneous rate of change of sine at x equals pi over 6. But for 0.0001, we get this value back, and we kind of estimate it there and say that's probably good enough.